In this lesson, we'll talk about how to graph a sine curve when the period has changed. Whenever you're graphing a sine curve, you want to first start off with the basic parent function, the basic sine parent function. The sine parent function starts at the origin, 0, 0. Next, before you graph any trig function, you always want to find three things: the y-intercepts, the x-intercepts, and the maximums and minimums. So we're first started with the y-intercept, which is 0, 0. The x-intercept is pi 0 and 2 pi 0. Then you go to the maximums and minimums of the graph. The maximum of the sine curve is pi over 2, 1. The minimum of the sine curve is 3 pi over 2, negative 1. And then all you do is connect the dots. Whoa, I missed one dot. This will give you the parent function of the y equals sine of x curve, the parent function of the sine curve. So that is one full period. In order to find how to graph that same period, one full cycle, with a smaller or larger period, you should first split it up into fourths. So this is 1/4, this is 1/4, and this is 1/4, and this is another fourth. So you see you have 1/4 of the graph here, 1/4 of the graph here, 1/4 of the graph here, and 1/4 of the graph here. You should also notice that at every fourth of the graph there's a key point. Here is a maximum, here is an x-intercept, here is a minimum, and here is an x-intercept. And that's one full cycle of the sine of x curve. So if your period changes, you want the same type of curve, but in either a smaller cycle or a smaller period or a larger period. So let's, for example, say that the period decreased and now our new period is pi. So on the parent function, the period is 2 pi. Let's say on our new function, the period is now equal to pi. So I start off in the same way. I know one full cycle is going to end at pi. So I graph my y-intercepts and my x-intercepts. Well, I'm still starting at the same spot, which is 0, 0. So that's my y-intercept. My x-intercept, One of them is where the first full cycle ends, which is pi. Now, if you recall from our previous graph, that halfway between 2 pi and 0, that's where my next x-intercept was. So I'm going to use the same logic here. Halfway between the beginning and the end of my cycle is pi over 2. So that's where my y-intercept, my x-intercept would be. I'm going to continue to break the pi period into fourths. So half of between 0 and pi over 2, halfway between would be a fourth. Between pi over 2 and pi, halfway between would be a fourth. So that is important so I can know where my other key points are. As you recall earlier, after 1/4 of the graph, my first key point, which was my maximum, was located there. The same thing happens here. After one key point of my graph, my maximum will be located there. If you recall earlier, after 1, 2, 3/4 of my graph, I had another key point, which is where my minimum was. So the same thing is here. After 1, 2, 3/4 of my graph, that's where my maximum will be. So now I have my y-intercepts, I have my x-intercepts, and I have my maximum and minimum. So now I can connect the points to get one full cycle of my new graph. My new period is now only pi, and my previous period was 2 pi. The period was cut in half, so my one full cycle took half the time to complete on the graph.